Let us take an example. It is question number 1 taken by me as example here for a particle which moves along a straight line. Here I am taking various positions of the particle. I am taking these positions. Just I am pointing here the time t 4, 3, 2, 1 and 0. I am taking these values to be the values of time. Here at time 4 second, at time 3 second, at time 2 second, 1 second and at time t equal to 0. I am just giving you the position of the particle at these different times. At t equal to 0 particle was here, at t equal to 1 second particle was here, at t equal to 2 second, 3 second and 4 second particle was at the positions along the straight line as shown in the figure. What we have to do is, we have to draw a position time curve for this particle. How will we do it? As here no sharp values of its positions are given, so we just take an approximate idea. Here you can see that between time t equal to 0 to 1 second, particle moves this much distance, while for the coming intervals between 1 to 2 seconds, particle travels a little less distance than between 0 to 1. And in the successive time intervals of equal time, 1 second, are considered, then distance traveled by the particle in that particular interval is decreasing. So what will we do for drawing position time curve here? We are taking time on this axis and position x at this axis. Here we have been given only the values of time, so it will be better that I draw equal time intervals here on this axis. You can see here corresponding time is 0, here 1 second, here 2 second, 3 second, 4 second, 5 second and so on. Now see that at time t1, at time t equal to 0, particle was at the x equal to 0. I have chosen this x equal to 0 at time t equal to 0 is per my own convenience. You can take it at some other place also, say here or here, depending upon your mood. So just see, I have drawn x equal to 0 at time 0. So my first point object was at x equal to 0 at time t equal to 0. Now in this time interval 0 to 1 second, particle moves a distance, say this much. Say this is delta x1, which has been traveled by the particle in the first second of its motion. If you see, for the time interval between 1 to 2 seconds, the displacement is a little less, say delta x2. No doubt at time t2 this point will occur here at this place, while the position of the particle at time t equal to 1 can be drawn here. For the next time between 2 to 3 seconds, you can further see that distance moved by the particle, just mark it with delta x3, it becomes some more little than delta x2. So the corresponding point on the xt diagram will be somewhere here. If we talk about further 3 to 4 seconds, then the corresponding position after 4 seconds may be at this point. If you connect all these points with a smooth line, what you got a curve of this shape. So this is the position time curve for the particle whose positions are shown in the figure. Now in this question I have taken x to be positive from right to left side, what will be the nature of the same curve? How will you draw the same curve? It is my question for you. I have solved one part of this question by taking to be x as positive and left side. But what will happen if I take positive x to be from left to right? No doubt, particle is moving here at the left side while the x is positive to right side. So what will we achieve here? You can draw this curve just in this mean that at t equal to 0 particle's position is farthest, because you can say it is more positive. So I can draw the initial position of the particle, say here. Initially, change in x for first second, it becomes larger than for the rest time intervals, and as we know, slope to the xt curve, as change in x is larger in a first second, then no doubt the curve will be somewhat in this way. Slope is more because change in position is more. If we talk about next time 1 to 2 seconds, then obviously as displacement during this second, it becomes a little less. So you can draw this curve with some less slope. If we talk about 2 to 3 seconds time interval, it becomes some more flattened, and as the motion progresses, particles change with time, it becomes less. So what will we achieve from here? I have just drawn this curve. If x is taken as positive in the right side direction, and if I draw x to be positive due this direction, then the curve to this particle for the demonstrated observations, then the curve will be something like. I think you may have got the entire details of particles motion from this position time curve.